This is 10.4, surface areas and volumes of similar solids. Similar solids have the same shape and have proportional corresponding dimensions. So which cylinder is similar to cylinder A? So here's cylinder A. Is B similar or C similar? To do that, I'm going to set up some proportions comparing A and B. So I'm going to put the height of A over the height of B. So that's 4 over 7. Then I have the radius of A over the radius of B, which is 6 over 8. So these are their corresponding parts, the parts that match, radius to radius, height to height, and so on. So these two fractions are not the same, so the cylinders are not similar. So let's check A and C. Height of A over height of C is 4/5, which could be written as 0.8. Then the radius of A over the radius of C is 6 over 7.5, which also can be written as 0.8. These fractions are equivalent, and so the cylinders are similar. For proportional figures, we could put dimension over dimension, where we have the same figure on numerators and same figure in denominators, and the same dimension would be in the heights, in the one fraction. So we can write that a couple different ways. I could have height of A over radius of A, so that's the same figure. And then the same dimensions would be numerators and denominators. Or you can set up your proportion height of A over height of B, just like I did in the other examples, and the radius of A over the radius of B, or whatever dimension they give you here. So to find the missing measure of the similar solids, I'm going to set this up so I have the radius of x over the radius of y equals the slant, that's this diagonal edge, slant of x over slant of y. So that's 5 over 7 equals 13 over L, because I don't know the slant of y. Then you cross multiply, and you get 91 equals 5L, divide each side by 5, and solve for L, and L is 18.2. For these two rectangular prisms, I'm going to put the height of A over the height of B equals the width of A over the width of B. So I have 9 over H equals 3 over 2. Cross multiply and solve for H, and H is 6. If we are given surface areas, you have the surface area of A over the surface area of B equals their dimensions, the dimension of A over the corresponding dimension of B, squared. So, given the information I have, I'm going to plug it into this proportion. So I have the surface area of A over the surface area of B equals the height of A over the height of B squared. So that's 600 over B equals 10 over 6 squared. 10 over 6 squared is 100 over 36. Now cross multiply, and 21,600 equals 100B. Divide each side by 100, and B equals 216. If we are given volume, it's the same deal as surface area, except the dimensions are cubed. So we are going to find the missing measure. Filling in volume of A and B, radius of A and B, I have A over 288 equals 5 over 12 cubed. When I cube these, I get 125 over 1728. Then you cross multiply and solve for A, and you get 20.83 equals A. For these square pyramids, filling in my volumes, 9 over B equals 3 over 4 cubed. 3 over 4 cubed is 27 over 64. Cross multiply and solve for B, and B is 21.3. The dimensions of a kiddie pool are doubled. how many pounds of water are contained in the new pool? 1 cubic foot of water weighs about 62.5 pounds. So here's the volume of the kiddie pool. That's the old one. So then I have old volume over new volume. If the old volume is worth 1, the new volume is worth 2 because it's doubled. So then I have 2,000 over n equals 1/2 cubed, which is 2,000 over n equals 1/8. Then 2,000 times 8 is 16,000, so that is n. Now I need to find how many pounds that is, so I multiply by how many pounds are in 1 cubic foot. So that's 16,000 times 62.5, which is 1 million pounds.